In this video, we want to calculate the ranks of poker hands. So if you've ever thought about the game of poker, and maybe who invented it and why they decided that, for example, four of a kind beats a full house or a flush beats a straight, then what we want to show in this video is that that's not exactly the way things are. There's actually a precise mathematical reason why, for example, a four of a kind beats a full house. And any hand that beats any other hand beats it because it is less likely. So the less likely hand wins. And we will be using one particular mathematical tool to do these calculations called the binomial coefficient. It's defined this way. If I have n things and I want to choose k of them, then it turns out that the number of combinations I can make is n factorial divided by k factorial divided by the difference factorial. So, for example, if I wanted to calculate the number of poker hands, then I would have 52 cards. So we're not counting jokers. And since a poker hand has 5 cards in it, we would choose 5 of those. Now I would just write out this definition here. So I have 52 factorial, which just means 52 times 51 times 50 times 49 all the way down to 1, divided by 5 factorial, 5 times 4 times 3 times 2 times 1, divided by 47 factorial. You might be interested in why we're doing this division here. This particular division here with the 5 factorial, that makes sure that we're not counting things doubled. For example, if I had the hand ace of hearts, deuce of hearts, trey of hearts, 4 of hearts, 5 of hearts, that would be the same hand as 5 of hearts, 4 of hearts, trey of hearts, deuce of hearts, ace of hearts, right? So the actual order of the cards in my hand, for example, plays no role, or the order in which they're dealt. So we want to make sure that we're not double counting. That's what that's about. Anyway, it turns out that this number here indeed counts the number of combinations. If you have 52 things and pick 5 of them, this is the number of combinations you get. And that number turns out to be 2,598,960, so about 2.5 million. So what we want to do now is go through the ranks of the cards. So we start with a straight flush, 4 of a kind, full house, flush, straight, 3 of a kind, 2 pair, 1 pair, all the way down to high card. High card, in other words, when you don't have jack squat, right? You don't have anything. You have maybe a 6, 7, 8, 10, and a king. Good. You'd say, well, the king's the best I got. Okay, so let's do this. We have 10 choose 1. Now, why do we have that? Well, let's think about this before we get into the nitty-gritty. Let's imagine that we're working at someone's playing poker, and we're the poker gods or the probability gods or something, and we're having to make choices. If we say this player needs to have a straight flush, then let's think about this in terms of how many choices do I have to make? Right? This is called n choose k, 52 choose 5, 10 choose 1. I'm going to have to make choices. I'm going to be choosing. What do I have to choose in order to define a particular straight flush? So let's think about it this way. We have a straight aspect and a flush aspect. Let's think of the straight first. If you have a straight, if you think about it, if you know the lowest card of the straight, you know all the rest of the cards, right? So if I know the lowest card is a 5, then I know the other ones must be 6, 7, 8, and 9, right? I could also know the highest card or the middle card, or I could know any card as long as I know its position. But it turns out that if we just make one choice here, we choose from the 10 cards that can begin a straight, we choose one of those. Well, what are the 10 cards that could begin a straight? It could be an ace, deuce, tray, 4, 5, right? We could have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Those could always be the lowest notes, the lowest cards, rather, of a straight. If you have any higher than a jack, any higher than a 10, you have jack, queen, king, ace, you don't have enough room for 5 cards. So we're going to be choosing one card of the 10 possible ones. Let's choose an ace, let's say. And then we're almost through with the straight flush. We just have to think of the flush aspect. Of the 4 suits there are, so spades, hearts, clubs, and diamonds, we need to choose one of them. So we already picked an ace for this choice, and now let's pick a heart for this choice. That would give us this particular straight flush. It turns out, if you multiply this out, that you get the number 40. There are precisely 40 straight flushes that you could have, one of which is the famous royal straight flush, 10, jack, queen, king, ace of 1 suit. Okay, so let's move on to the 4 of a kind. Now here we're also going to have to make some choices. This time we'll be making 3 choices. Of the 13 values that we have in a deck of cards, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then jack, queen, king, right? That's 13. The ace could be low or the ace could be high. It doesn't matter here. We have 13 different values to choose from. We're going to choose 2 of them. Now you might ask yourself, why 2? We just want to have 4 of a kind. Well, if you have 4 of a kind, then you have 4 of one value and 1 of another value, right? So altogether you have 2 values. So let's choose those. Now let's say we want an ace and a king, let's say. So I'll get an ace and a king. And then we have to make a further choice in order to define this particular hand. We have to choose which one of these, the ace or the king, is going to be the 4 of a kind. Let's say the ace is the 4 of a kind. So we have made that decision. And now we have one more decision. For the aces, we don't have to make any decisions because all 4 of the aces are going to be there. So that just follows from our other decision. But for the king, we are going to have to make a decision. That is what suit it will be. Let's pick, of the 4 suits, let's pick one of them. Let's pick spades. That would give us this hand here. 4 of a kind. Now let's move on to a full house. And there's something interesting about a full house in connection with 4 of a kind. They're the only 2 hands that only have 2 values. So you see, with a full house, we're also going to start with 13 values. And we're going to choose 2 of them, just like we did with 4 of a kind. And then we're going to make a choice which one of these 2 values is going to be the 3 of a kind, let's say, because in full house we have 3 of a kind in a pair. So we'll choose one of them to be the 3 of a kind. And then of the 4 suits, we're going to have to choose 3 of them for the 3 of a kind. And then of the 4 suits, we're going to have to choose 2 for the 2 of a kind, so for the pair. And you can see that these begin rather the same, right? 13 choose 2, 2 choose 1, 2 choose 1. For 4 of a kind, we have 4 choose 1. And for full house, we have 4 choose 3. It turns out this is the same number. So how many ways are there of choosing one suit of the 4? Well, there are 4 different ways, right? You could choose spades, hearts, clubs, or diamonds. How many different ways are there of choosing 3 suits? Well, each time one of them you're leaving out, right? So you could leave out spades, hearts, clubs, or diamonds, right? So it turns out that up to here, these numbers are the same. And then with a full house, you get an additional factor here. So it turns out that the number of 4 of a kind are 624, and the number of full houses is 3,744, which works out to exactly 6 times as many as for the 4 of a kind. So from a straight flush up to a 4 of a kind, this is like 15 and a half times as likely as that, and this is 6 times as likely as that. So let's build our full house. So we have to choose 2 cards of the 13 values. Let's pick an ace and a king again. We'll do that again. And then we have to choose one of them to be the 3 of a kind. So let's say we pick the king this time. And then we have to choose 3 suits of the 4 for the king. So let's pick spades, hearts, and clubs. And then for the pair, we need to choose 2 of the 4 suits. Let's pick diamonds and spades. That gives us this hand here. Okay, now we move on to the flush. We've already talked about a flush before in connection with the royal straight flushes and the straight flushes in general. What do we do here? Well, we have 13 values, and we're going to choose 5 of them, right? Because a flush is just when you have 5 cards of one suit. There can be no repetitions, right? You can't have 2 6 of hearts in a deck. So you need 5 values of the 13. Let's pick 5, 6, 7, 8, 9. No, we have to watch out, don't we? We don't want to do that because it would also be a straight. So we'll have to remember that. Let's pick 5, 6, 7, 8, 10. And then we have to pick 1 suit. So let's pick hearts. So we have a 5, 6, 7, 8, and then a 10 of hearts, which gives us this. So you see that these hands are happening just through our decisions. We made these 2 decisions, and then we have our particular hand. And as we mentioned before, we have to be careful here because a flush could also be a straight flush, and we don't want to count that twice, so we will subtract 40 here. And it turns out that the number will be 5,108. So there are 5,108 different flushes that you could have of the 2.5 million poker hands. Now, for a straight, we already talked about a straight here with the straight flush. So again, we just pick one of the 10 values that could be the lowest card in a flush, right? Let's pick a 7, let's say. And then the rest of the values follow. So there must be a 7, 8, 9, 10, and jack in that case. And then we just have to choose one of the 4 suits. We just have to do that 5 times, yeah? Hence the 5 here. So we're doing that 5 times. So let's choose a 7 of hearts, an 8 of hearts, maybe 9 of spades, a 10 of hearts, and a jack of hearts. So I had to be careful there that I didn't pick the 7 of hearts, 8 of hearts, 9 of hearts, 10 of hearts, jack of hearts, right? I picked the 9 of spades. Because had I picked the 9 of hearts, then I also would have had a flush. And we would have had a straight flush. And we've already counted the straight flushes. So we have to remember to subtract something here. Subtract 40 before we get ahead of ourselves here. And it turns out if we subtract those 40, then there are 10,200 straights. So they're about twice as likely as a flush. Okay, so we'll move on to 3 of a kind. With 3 of a kind, there are 3 different values that we have, right? We have 3 of a kind itself, and then we have 2 extra cards. So that's why we choose 3 of 13, right? And then of these 3, we have to choose one to be our appointed 3 of a kind. So let's choose, let's say 8, 9, 10. We'll choose 8, 9, 10 for our values. And then we choose one of these to be the 3 of a kind. Let's say we pick the 8. And then for the 8s, we're going to have to pick 3 suits of the possible 4. So we'll pick hearts, spades, and clubs, let's say. And then for the 2 single cards, we'll need to choose one of the 4 suits. So we'll pick the spade for the 9 and a heart for the 10, right? Which would give us this hand here. So again, this hand just arose out of those choices that we're making. And that's why the figuring out the number of those choices gives us the likelihood of each one of these hands. Turns out that there are 54,912 different 3 of a kind hands. So you see it's about 5 times as likely as having a straight. Now, you might have thought, isn't there a different way we could do this? And certainly there is, but you might have thought, why don't we just pick 13, choose 1? So we're going to choose our number for the 3 of a kind. And then we don't have to do this thing here with picking one of them. I'll just pick 13, choose 1, and then I'll pick the suits for it. And then for the single cards, I'll just think, well, there are 12 remaining values. So of the 12 remaining values, I'll pick 1. And then of the 11 remaining values, after I've taken that card, I'll pick 1 there too. And then again, I'll just pick a suit for those. Why don't I do it this way? Why do I have to pick 3 at the beginning and then do this choice here? And the reason for that is that you do indeed get a different answer by doing that. Which I've written out here. If we do this like I've written it out, we have 13 choose 3 times 3 choose 1. We end up with this. If we do indeed pick 13, out of the 13 we choose 1, and then out of the remaining 12 we choose 1, and out of the remaining 11 we choose 1, we actually end up getting a number that's twice as big. And the reason is because of the order. If you have the 2 remaining cards in a 3 of a kind, for example, one's an ace and one's a king of, let's say, spades, it wouldn't make any difference if you had the king of spades and then the ace of spades, right? It's the same thing. So you don't want to count them double. And what choosing these at one time does is that it accounts for that. If you're choosing them one after each other, then what you're actually doing is you're double counting. Okay, so let's do 2 pair now. Just like 4 of a kind and full house were connected by us choosing 2 values of the 13 and then choosing one of those to be the anointed group to be either a 4 of a kind or the 3 of a kind, the same situation pertains here for 3 of a kind and 2 pair. We have 3 different values, right? So if you have 3 of a kind, you have 3 of a kind and 2 extra cards. And if you have 2 pair, you also have 1 pair and another pair and then an extra card. So you have 3 values that you're dealing with. So you have 13 choose 3. Then you have to choose one of these to be the one left out, right? 2 of them will be pairs, and one of them will just be a single card at the end. And once you do that, you have to choose for the pairs, you have to choose 2 of the 4 suits. For the next pair, of course, you have to choose again 2 of the 4 suits, hence the 2 here, the square. And then for the remaining card, you have to choose one of the 4 suits. So let's do that. Let's say of the 13 cards, of the 13 values rather, let's pick an ace. And for the other value, we'll pick an 8. And for the leftover card, well, actually, we'll just pick an ace and an 8 and a queen now. Ace and an 8 and a queen. And then for the choice here of what will be the leftover card. We'll pick the queen, let's say. And then we need to pick 2 suits for the one pair. So we'll pick, let's see, spades and clubs for the ace. And for the other pair, we'll also pick spades and clubs. And for the leftover queen, we will pick a club. So that gives us this hand here. And we will now write out the number of possible 2-pair hands. That is 123,552. So you see that is somewhat more than twice as likely as having 3 of a kind. So let's move on to one pair. Here we have 4 different values, right? So you have the pair and then 3 leftover cards, so 4 values altogether. And then of these 4 values, we have to choose one of them to be the pair itself. So let's do that. Let's pick 8, 9, 10, and Jack, let's say. And one of those needs to be the pair. Let's pick the 8. And then for the 8s, we need 2 of the 4 suits. So let's say 8 of spades and 8 of diamonds, let's say. And then for each of the leftover cards, we need 1 suit. So let's pick for the 9, we'll pick spades. For the 10, we'll pick hearts. And for the Jack, we'll also pick hearts, which gives us this hand here. And again, that gives us a particular number of combinations for one pair. That number is 1,098,240, which is about 8 times as likely as having 2 of a pair. Okay, so the last one we need to do is high card. In other words, when you don't really have anything. We have to be careful here because we're picking 5 different values, and straights also have 5 different values, as do flushes, and of course straight flushes. So what we're going to do is, after we pick those 5 values, for each one of those values we're going to have to pick a suit. So let's say I pick the even numbers, let's say here, 2, 4, 6, 8, and 10. And the suits that I pick are, let's say, a heart, a heart, a heart, and a diamond, and a spade, right? That gives us this hand here. Now, as I said, we have to be careful here when we're calculating this, since we do not want to count the straight flushes or the flushes or the straights. And if we are that careful, then we get the number 1,302,540. And if we compare that number with the number that we got at the beginning, the 2.5 million, then you see that somewhat more than half of the time, if you're playing, let's say, 5-card draw, where you actually have 5 cards in your hand, that you will be dealt a high card hand. Okay, so you see that is how you calculate precisely, mathematically, the ranks of poker hands.